All right, so in this video, what I am going to do is I'm just going to do all of page 41, page 149, number 5i. And the reason for this is because there is an answer in the workbook, that is wrong. So let's see why it's wrong. The question here is really just find the y-intercept. And if you have a question that says, okay, find the y-intercept, and maybe you have some graph that maybe looks like this and just clearly passes through all these points, right? And maybe with this particular graph, maybe it is just very, very clear that this y-intercept is at 1, 2, 3. The exact point would be 0, 3. Then feel free to do that. Feel free to point out that, hey, this line is clearly crossing the y-axis at 3. And so I'm just going to say that. I don't need to make an equation. I don't need to do any of that. It clearly crosses at y equals 3, so there you go. I'm happy. We're good to go. But sometimes we get lines that don't necessarily clearly cross the y-intercept at a specific value. So this is one of those cases. I've pretty much just copied this particular line from the workbook for number 5i. Now let's take a look at this. Here, this line crosses the y-axis, and it's not crossing the y-axis at -4. It's not crossing the y-axis at -5. It's crossing the y-axis somewhere in between. And so what you shouldn't do in this particular case, what you shouldn't do is say, oh, this crosses maybe roughly at -4.5. Don't do that, because it's simply not accurate. And when we have an equation, or sorry, when we have a line that's crossing the y-axis at a place that clearly isn't an integer, then we need to be more precise. So saying simply it looks like -4.5, that will not do. That will not do. So here's what you do in this case, and this is more difficult, but it's more precise and it's actually correct. So what we can do if we want to find the y-intercept, and it's not clearly at one specific integer, it's maybe in between two integers, -4 and -5. What you'll need to do is first find the slope. So first, we'll find the slope of this line. Let's choose two clear points where we have the line crossing through an intersection of grid lines. So it's clearly crossing at some integer coordinates. So if we follow along this line, here is a clear case where the line is crossing an intersection of grid lines. So it has integer coordinates at -5. And what is the y value here? 1, 2, 3, 4. And then let's keep going down, keep going down, keep going down, keep going down, keep going down. Here is another spot where this particular line clearly crosses at integer coordinates. It crosses an intersection of grid lines, so it has integer coordinates at -2 and -1. So let's say this is our first point, and this is our second point, and let's say that we want to travel from point A to point B. If we want to travel from point A to point B, but we can only go up, down, left, and right, well, we're for sure going to have to go down. So we'll go down. So we go down to the height of point B. So now we're at the height of point B. How far down did we have to go? Well, we had to go down by 1, 2, 3, 4, 5 units. So the rise is 5. But we went down to do that, so it's -5. So we have a directional component here. It's -5 because we're going down. Then, now that we're at the height of point B from point A by going down by 5 units, we now need to travel to the right. So we travel to the right by a certain number of units. How many units did we need to travel to the right by? Well, 1, 2, 3 units. So we would say our run is 3. So The reason we have to do this is because to find the y-intercept here, we're actually going to need the slope. So the slope, m, is really just the rise over the run. The rise is -5, the run is 3. And now what we're going to do with this slope is we are going to look at our equation. Our equation should eventually look like y equals something times x plus something. And one thing we can fill in is this m value. So we now have y equals -5/3 times x plus b. Great. So we kind of almost have an equation for this line. All that we're missing is this b value here. And it's important that we're missing this b value because this is actually our y-intercept. And that is what we need to find in the first place. So if we find this b value, then we've found the y-intercept and we're done. So let's do that. Let's find the y-intercept here. So to find the y-intercept, what we can do is we can plug in some specific value of y and some corresponding specific value of x that we know is true for this line. So let's give that a shot. We know that for this particular line, which this equation models, we know that, it's preventing me from scrolling up here. We know that when x is -5, y must be 4. Okay, so when x is -5, y must be 4 for this particular line, and thus for this particular equation that must be true. So let's fill in the rest of what we know about this equation. Okay, so what we've done, again, I want to remind you, what we've done in a step-by-step fashion is we started filling in this slope-intercept equation, which is an equation that we know could model this line or match that line. We know how to find the slope of that line just by counting the rise over the run, so we plugged in the slope of that line. And then to find the only real missing part of this equation, the y-intercept, what we do is we substitute in corresponding values of y and x that we know are true for that line. So for this particular line, we know the point -5 and 4. We know the point -5 and 4 is on that line. So we know for this corresponding equation, when x is -5, y then must be 4. So what is a b value that makes that true? So let's give this a shot. If we start doing some algebra here, and some calculations and some simplifications, we can say, okay, -5/3 times -5, that is just 25/3. Right? This -5 we could really see as a fraction where we multiply the numerators. -5 times -5 is 25. 3 times 1 is 3. We want to isolate the b value. That's ultimately what we want to solve for. So what we can do here is we can get rid of this constant that's being added to it. So we'll subtract 25/3 to get rid of it. But we need to do that on the left-hand side as well, so -25/3. So we have 4 minus 25/3 is equal to b. Right? So we have our b value. Our b value is just this, 4 minus 25/3. We can figure out more specifically what this is, and we will want to do that for a final answer. So let's turn 4 into a fraction with the same denominator. Currently, it's a fraction that has a different denominator. So what would we do to this fraction to make it have the same denominator? We would multiply the denominator of this fraction by 3, but to make that allowable, we also have to scale up the numerator by 3 as well. So when we do that, we will then have, and I want to make this clear, it almost looks like I'm writing 4.3, but I'm writing 4 times 3. And when we do that, we're going to have 12 minus 25 over a common denominator of 3 now, right? This denominator is now 3, so we can collect that all over one fraction bar. And what is 12 minus 25? Last time I checked, that was minus 13. So this is your b value. This is your y-intercept. This is your answer. So here we can say, what is the y-intercept? Well, the y-intercept is at 0 and negative 13 over 3. If you want to put that into a decimal, you could say it is 0 and negative, what would that be, 4.3 repeating. So totally up to you whether or not you want to write this as a fraction or as a decimal, but it is clearly not at 0 and negative 4.5 like the workbook claims it to be. So we have a superior answer here. We have an answer that is actually representative of this line where it crosses the y-axis. It's not just a guess. We know for sure that it crosses exactly at 0 and negative 13 over 3. So there you go. Hopefully that's helpful. I know it's difficult. This is probably one of the most difficult ways to find a y-intercept, but we are forced to use this method to find y-intercepts when we have the line clearly crossing at a non-integer value.